All right, so I think we can get started. So my name is Yuichi Kurihashi from Fujifilm Corporation. I'm going to talk about a new object-based tape system in managing the exponential data growth. We also have Haru as a co-speaker. He's from headquarters Tokyo Fujifilm Corporation. So today I'm going to talk about the first, exponential data growth, and second, predominance of object storage, and then I'm going to cover why we should or we use tape for object-based storage system. And then after that, Haru Oki is going to go into detail about object-based tape system. And lastly, Q&A. So exponential data growth. Here is the exponential chart is showing exponential data growth. And x-axis is showing year, and y is capacity in petabyte. And as you can see, orange bar is showing worldwide installed byte, and gray one is stored byte. And 2019, almost 6 petabyte was installed, and almost 3 zettabyte was stored. And data is keep growing, and by 2025, almost 13 zettabyte will be installed, and 8 zettabyte will be stored, according to this survey. So as I said, data is keep growing, but requirement for access time is not the same. So here is the assumption for cold storage, which is primarily our focus. So according to the same survey, by 2025, almost 7 zettabyte was created annually, and 40% of data is corporate data to be captured, which is equal to almost 3 zettabyte. And in this 3 zettabyte, and 10% is hot data. And here is the definition of hot data. Hot data meaning the expectation of access time is within 10 days. And we also have warm data. It's 30%. And it's the expectation of access time is within 30 days. And lastly, we have cold data, which is 60%. And 6% cold data is meaning that the expectation of access time is more than 30 days. So as I said, data is growing, and majority of data is cold, which is infrequently accessed. So here is the predominance of object storage. So this chart is showing worldwide file and object-based storage capacity shipment by segment. And x-axis is year, and y-axis is capacity in exabyte. And green color showing scaled object storage, which is primarily for hyperscale data center, which means I think mainly cloud. And yellow one is scale-out object storage, but this is non-hyperscale data center. And blue one is scale-out file storage, and red one is scale-up file storage, which is conventional data storage system. And as you can see here, data growth is mainly supported by hyperscale data center. But so if we remove hyperscale data center, I just removed green. So as you can see here, in non-hyperscale data center, you can clearly see data growth in scale-out object storage, which is our primary focus for us. So, in this existing object storage, here is the main applications. And as you might know, object storage is very suitable solution for cold data. And this chart is showing the existing use case for object storage. And blue one is current use cases, and yellow one is the future use cases. And as you can see here, backup is the most popular use case. And after that, production data and active archive, and also shared for remote access. And we also have deep or cold archive. So this chart is clearly showing that object storage is best solution for cold data. So, but there is an engineering need to optimize TCO in object storage. So left-hand side is showing the existing object storage architecture. And in this currently, object storage only supports HDDs mainly. But as I said, cold data is growing. So you have to keep adding HDDs more and more, so which means quite expensive. And you have to always spin up these HDDs for cold data, but cold data is, as I said, infrequent access. So our proposal is to mainly create tier in the object storage system, and then offload to growing cold object to low-cost devices such as tape and optical disk, whatever. So we have multiple choices for storage devices, and here is a specification comparison between tape and capacity optimized HDD and optical disk. So for tape, capacity is up to 20 terabyte per cartridge in the latest 3592 product. And also, when it comes to HDD, it's up to 16 terabyte, and optical disk is 0.3 per disk. And transfer rate in the existing enterprise drive, it supports up to 400 megabytes per second. But HDD is slightly slower, up to 260, and inner is slower. And optical disk is up to 140 for write and 280 for read. And of course, inner side is slower. And access time, tape, second to minutes. HDD is faster, millisecond order, and optical disk is also have a second to minutes of access time. So media lifetime is a very important indicator for cold storage devices. And for tape, lifetime is beyond 50 years. But HDD up to 5 years. But optical disk has a superior media lifetime, 100 years. And here is the bit error rate comparison. Tape is 10 to the minus 20, and HDD is 10 to the minus 16. So tape has a superior reliability. So, and also data verification. Tape drive supports in-drive read while write verification. So no performance penalty. HDDs and optical disk is kind of option, and we also have performance penalty. And media technology, tape employs a barium ferrite particle, which is a magnetic particle to store a bit, and that has a superior recording performance. HDDs, SMR, helium shield drive, and optical disk is multi-layers. That's pretty much about current product, but not only current product, future is tape storage demonstrated 400 terabyte per cartridge with using a new strontium particle, and also 220 terabyte per cartridge with using barium ferrite particle. And it is said that 20 terabyte capacity will be released 2020, and optical disk is 1 terabyte. And transfer rate, more could be, because the existing tape drive has 32 channels just for one head, and we can increase, if we increase the channels, transfer rate can be doubled. So HDD is limited, transfer rate is limited due to a rotation speed, and I think optical disk is almost the same situation. So why tape now? So here is the roadmap for HDDs and tape, and x-axis is year, and y-axis is area density. And blue point is showing HDD's area density demonstration. And the red one is showing HDD products. And light blue is showing tape demonstration. And light green is showing tape product. So as you can see, for tape storage, we're going to double the capacity for each generation. This is another roadmap from linear tape open format, which is called LTO. And we have just released LTO Gen 8, which is 12 terabyte. And as you can see, we're going to double the capacity per each generation, which means Gen 9 has 24 terabyte. And roadmap lasts until Gen 12, up to 192 terabyte. So the most significant benefit of tape is superior TCO. And here is the TCO comparison between all disk, all cloud, and LTO-8 technology. And this assumption is based on 10 years expected total cost. And as you can see, LTO-8 technology has a superior TCO compared to all disk and all cloud environments. So it's really important for customer to optimize TCO by using such low-cost media devices. So since tape storage has a superior TCO, there are many tape users here. So segment is quite wide, research field, M&E field, methodology field, engineering, manufacturing, preservation, and cloud service provider, such as Google, Microsoft, IBM. So according to this source, approximately 90% of Fortune 500 companies have tape implemented in their infrastructure. So I'm going to switch to Haru. He's going to
Okay, so again, I'm Harunobu Oki from Fujifilm Corporation. I'm based out of Tokyo. Please call me Haru in short. And so now I'm going to give you a brief overview of the object-based tape system that we're developing in Fujifilm. Before I start, I just wanted to tell you how happy I am to see such a big audience today here, because we know tape is not the sexiest technology in the storage industry today, but we believe that tape still has a very important role, especially with the exponential data growth in helping people manage their a massive amount of data for long-term preservation and, of course, data protection. So this is a diagram of our system, this box in the middle of the object-based tape system that we're developing. In a nutshell, it is an S3 compatible object-based tape system, and it has basically three major components. So starting on the very left, we have the front end of the system, where we have an S3 API front end. So we're using, and we're calling this the S3 Glacier server. And the reason for that is, first of all, we are using standard S3 APIs. And then among the S3 APIs, we're using the S3 Glacier APIs to recall data out of the tapes. And I will explain that in more detail in a following slide. So when you write data to the system, the data objects will come in through the front-end server, and then they will be accumulated in this cache system, in the disk cache in the middle. And we will accumulate objects and for a certain period of time, and then we will pack them into larger objects before they are written out to tape in order to optimize the write performance of tape. And so this is kind of like a staging area for accumulation of objects and then packing them into a larger object. And then we also use the disk cache for when we read out the data out of the tapes. So when we read the data out of the tapes, the packed object would be restored back from tape back onto this cache and then opened up to be made available for reading of the data from the front end. And then on the right, we have the tape operations part of the system, which basically does the tape device operations and management of the tape library, the tape drives. And then also we have the format controller, which basically controls writing these objects out to the tape. And so this software would be installed on a server and then connected to a tape library in actual implementation. And we are also developing a new tape format for object storage in this system. And this diagram on the right kind of gives you an idea what that looks like. And we have two partitions of the tape and one partition, we're calling the reference partition, where we are just storing the metadata of all of the objects that are written to the tape. And then we have the data partition, which is the larger part of the tape where we actually write out the data objects. And the features are that first, this is a format that writes objects directly to tape in its native form. And we are also making this a self-describing and open format. Since we have all the metadata written in this small partition of the tape, by reading through this area, you can quickly get information on all the objects that are written on this tape. And we want to make the specifications of this format open so that it's not going to be a Fujifilm proprietary format, again, making it open. And we're also interested to see if other vendors might be interested in applying this format as well. And also, as I mentioned in the previous slide, we are optimizing the performance by packing objects into larger objects. And so by doing this, we get good performance of the tape when we write the data on the tape. And then lastly, we will support LTO7 and higher generations. So as Yuichi mentioned, we just brought out LTO 8. So the system, when we introduce the system, it will support LTO 7 and 8 for starters. So now I'd like to talk about a couple of use cases that we have in mind for the system. And the first use case, the primary use case we have in mind is offloading of cold data from existing object storage platforms for long-term preservation of data and also storage cost optimization. So we've been talking to a couple of object storage vendors, customers, and object storage is growing, as Yuichi mentioned in his slides, because of many benefits in helping you manage data, especially in scalability and searchability. But basically, this is traditionally it's disk-based storage, and when this scales up to tens of petabytes or goes beyond 100 petabytes, then customers do start feeling the need to optimize their storage because it does tend to get expensive when you're just using disk. And so then there comes the need to tier off more cold data into a lower cost tier of storage, and that's where our object tape system comes in. So typically this would be based on a tiering policy from the object storage using S3 and sending out the cold data to the S3 target. So this is the primary use case for this system. Another use case we're thinking about is alternative to cloud archiving. And we hear a lot of customers are actually sending their archival data up in the cloud because we have a lot of archival cloud services out there as well, and their pricing is also decreasing constantly. But we do have customers, some customers who tell us that they prefer to keep certain types of data, such as highly confidential data or mission critical data on site, protected, and also on very reliable media. And so that's another use case of this system. So keeping certain data that you would not want to put up in the cloud because you really want to keep that data safe. So that would be a good use case for this system. And then also storage cost optimization as well, because I think everybody probably also knows that when you store lots and lots of data in the cloud, like petabytes of data, it does tend to get expensive, even if you're storing it in an archival cloud service. And the price per gigabyte could be low, but if you have petabytes of data, you do get charged on a monthly basis based on the capacity. That does tend to get expensive as well. So to simply help optimize your archiving costs, instead of putting massive amounts of archival data, everything in the cloud, you could perhaps use the cloud for more recent archival data, active archive data that needs more access, or that requires access from multiple locations. That kind of data would be very suitable to keep in the cloud. And then this system could be more for deep storage of super cold data, which you rarely would access, and that could be kept in our tape system, which would be much lower in cost, and of course very reliable as well. Another use case, so this is a completely different approach, but a third use case that we are proposing is keep an on-site copy of all of your data that's being sent to the cloud to prevent high egress costs in case you need to download all of your data out of the cloud for whatever reason. So everybody's sending their data up in the cloud nowadays because the cloud has a lot of benefits with various applications, features, and so which is great. And but what we're proposing here is for everything you're sending up in the cloud, let's keep a copy on-prem. And by using tape, that you can do that very cost effectively. And the reason for that is, again, if you need to download all of your data out of the cloud for whatever reason in the future, it could get very expensive because we all know downloading data out of the cloud, you get charged by the gigabyte. And then another thing is that depending on the bandwidth you have, that could also take a lot of time. So like if you have petabytes of data in the cloud, it could easily take months to get all that data out. So in order to kind of avoid that kind of situation, so like an insurance policy, keeping an on-site copy on tape for all the data you send up in the cloud, I think is a good idea. And then lastly, use case number 4, this is for increasing your data protection. And one thing we have here is file versioning. So this is not really a use case, but more it's a benefit that you would have from one of the features that we will provide is file versioning. We will support file versioning, this is supported in many object storage products as well. But by using file versioning, this could be used to protect your data from cyber threats. For example, like ransomware, because if you get your files affected by ransomware, you get your files encrypted, and then you're threatened to pay a ransom to decrypt your data and be able to read that again. In a file versioning environment, typically the affected file would be just created as a new file. So what you can do is you can just go back to the previous version before it was infected to restore your data, get access to it again. So if you need to go to the tape layer to do that, our system will support versioning. And then also, this is the more traditional use case for tape is to increase data protection, creating an offline or even an offsite copy of your data. And meaning creating the air gap of your data for ultimate protection, again, against cyber threats. So keeping your data completely isolated from your data environment so that it cannot be touched by any sort of malware. And so kind of like your last line of defense. And also this is a very good practice for disaster recovery purpose as well. So now I'm going to just talk very quickly about what the workflow would look like with our object-based tape system when you use it together with an existing object storage product. So on this diagram, we have on the very left here, we have the application or browser, or this could be like a data mover moving data from a primary storage to an object storage product. So this is basically accessing the object storage, and then the object storage would be tiering data off to our tape system. And the first thing you would do is to set a tiering policy. In S3, it's called lifecycle management. And you would set that by like X number of days from the creation of the data object. And then you could also filter by folders and tags and set that policy. And that policy would determine when and how the object should be tiered off to the tape system. So typically from the application side, you would write data. This doesn't necessarily need to be S3, but a lot of products do use S3. So you would write the data to the object store, and then the object storage would tier off the data based on this policy that you sent. And so we would be an S3 target for the tiering destination. And then when the objects are written to our system, they'll be accumulated in the disk cache, as I mentioned, and then packed into a larger object, and then written off the tape based on preset intervals. And so that's how kind of the flow of data would be from the application through the object storage and then into our tape system. And typically, the data objects would remain visible from the application, even though it's tiered off to tape, because this in the S3 standard would be basically same as being in Glacier. And so if the object storage supports the S3 storage class, it would appear, the storage class would appear as Glacier. And then now just talking about how the, the reading of data would happen is, so this is where the S3 Glacier API comes in, which I mentioned earlier. So with AWS Glacier, when you have data stored in Glacier, you first have to issue a request to restore the data out of Glacier back to S3 in order for these objects to become accessible. And so we use this feature, same feature, we use the S3 Glacier API to first restore the data out of the tapes back onto the disk cache of the system in order to make the objects accessible. And so first the process would start by first issuing the API is called post object restore. This is the S3 Glacier API. So you would issue this request from the application to the object storage, which would pass that through to our system. And then once we receive that request, then our object tape system will initiate the restore process of the objects from tape into the disk cache. What I'm not showing here is, so this could, depending on how busy the library is, this could be a very quick process. It could be, in the best case, it could be done in seconds if the tape is already mounted in the drive. But if the tape is very busy, sometimes it could take minutes. And so what a typical way a Glacier is implemented is that you can program your application to periodically poll the system. It issues, by issuing an API called head object, which is asking the status of the object, and you will get a response on if the restore process is ongoing or if it has been completed. And so you can also do that, issue the head object request to kind of confirm the status of the object. And once the object restore has been complete, meaning the objects are restored back from tape to the disk cache, then you can issue a normal GET request, again from the application to the object storage, which will pass that through, and then our system will return the data via the object storage to the application, and then the data can be read. So you can see that since we are using the S3 Glacier API, the read process is kind of, it's a two-step process. You first issue the post object restore, and then once the data is available on disk, then you issue the GET request to read the data. So kind of like you're doing a prefetch of the data that you want to read. This is a list of the APIs, the S3 APIs that we're planning to support in the system. You can see it's a relatively short list. I think the S3 API full stack is nearly 100, or it could be over 100 now. But we're just using the APIs that are necessary to write and read data out of the tape system. And lastly, kind of to share our plans for this system. Our initial release, we're planning in the first quarter of 2020. And we will provide this as a software solution. So we will specify the hardware, meaning the server that the software can be installed on. And then we will also, we are planning to make this software compatible with the key tape libraries out in the market, especially the large libraries, because again, we believe there's a good market opportunity for this kind of system for especially large object storage environments. And also one more thing, that we are starting the launch of this product in the US, Europe, and Japan initially. So that was pretty fast, but that's all I have for our presentation. So thank you very much again for listening. And let's open it up for questions. Yes, please.
Is there any data protection on data tape in terms of data replication?
Yes. So for Data protection. Our system will support creating copies of tape. And initially, we're planning to support making up to 3 copies of your data to increase data redundancy. Okay. Yes?
Tapes have tape drives, and then the tapes go inside.
Correct.
On your system, there is no need for replacement of these tapes out of the tape drives. They're just always on and there, or how does that work? How does the workflow work for replacing and why would you replace it?
Okay. Sure, it's okay. So we have, well, I'm going to go back. This is not a very pretty picture, but in the world of, we have these large device called a tape library, which can hold, a large tape library model can hold like thousands of tapes inside the library. And then it also has, it can also hold many tape drives, which actually loads the tape and then does the reading and writing of the tape. And so this is like a jukebox of LTO tapes that automatically does the loading and unloading of the tapes into the drives. And so each LTO tape, like with the latest LTO 8, is 12 terabytes per tape native capacity. But by loading thousands of LTO tapes in this device, you can scale this up very easily up to petabytes. And so that would be how it would be used.
2 more questions.
Sure.
One is this cache is a hard drive?
Yeah, the cache that we are using, yes, it would be hard drive. But we are also looking at possibly using flash for the cache as well.
The endurance would be a potentially interesting situation here because this lasts 50 years and this is like a long-term data.
Correct.
Another question on this. But do you replace that thing more often than this? Because your write buffer or cache will last only 5 years and you're taking everything through that cache, right?
Oh, right. Well, first of all, sorry, this is the object storage product, and then our cache would be more here. Yeah. So, but you're right. So the object storage in our system, you're right. If we're using disk for cache, which we will, then typically it might last for maybe only 5 years. So that would have to be periodically replaced. And so that's something that, yes, kind of in maintaining the system, that would be necessary.
And last question for me is, what kinds of things have to last 50 years or more than 50 years?
Well, that's a good question. I think there's a lot of there's a lot of things. A very I think a very easy example might be in the healthcare industry, where you have to store patient data for like the life of the patient, or even beyond the life of the patient. That would be easily exceed 50 years or so. But in the world of object storage, we still have a lot of customers. Like for example, in the media and entertainment industry, they store their content just pretty much indefinitely, just because of the value, the cultural value of their content. And then I'll just give you one more example. Is we have some customers in the manufacturing industry who have to store like quality assurance data of their products, and they have to store that. They are mandated to store that data in case they have any problems with their product in the future. And so, but you can think of, there's a lot of use cases that we hear from our tape customers in general. And so, and with this system, we're making it object friendly. So we're hoping that we can expand applications of tape for such use cases. Let's go from the gentleman in front. Those, yes. Yes, that's correct. Of course, we would prefer you buy Fujifilm tape, but yes, it will work with any tape. Yes. Sure.
On the redundancy curve, what's allowing tape to be more aggressive than hard drives?
Okay, I'm gonna, Yuichi, you can maybe answer that question. エリアルデンシティがなんでハードディスクに比べてあんなにアグレッシブに上がっていけるのかっていう。So just to repeat your question was on this curve, right? Okay.
So HDD is in general magnetic recording devices. So we have to really make bits small to achieve a really high recording density. But if we make it too small, magnetization will be disappear over time. So it's a kind of one physical limit for HDD devices. But compared to HDDs, tape magnetic particle is still larger than HDD devices. So we don't see any data loss due to small or over small particle. So that's why our tape area densities keep growing.
If I could throw in a comment.
Sure.
Tape is using basically the same kind of read-write head technology the disk has been using. Disk has reached a kind of a saturation point. Tape is several generations, maybe as much as a decade behind in terms of what we have applied to tape in terms of what's already been developed for disk. So we really have a proven roadmap yet to go of disk-developed technology that we can apply to tape to stay on that curve for another decade or so.
Right, because yes, as you just said, the red dots, this is, the disk, with disk, they are already at a very high recording density where tape is still, has a lot of room to grow because we're still down here. But the reason we're able to achieve very high capacities on tape is because we have a very long, about 1,000 meters of tape in one cartridge. So there's a lot of areal space that we can write to. And that's another reason why that we have this kind of, we can support this curve. Please. Yes, we are talking to a couple, yes. I think before our launch, yes, we will probably, hopefully make a big list. Any other questions?
So one other question, that's just curious. The latency is the main problem with the tape, right?
Right.
Everything else in your spec sheet looks better than, even the bandwidth is better than hard drives. The megabytes per second is better than the error rate. Everything is better except the latency, right?
With tape, yes. So the latency is one thing, and then just maybe add one more thing is that since tape it's a very long medium, it's also not it doesn't do well with random access. So that's another thing to keep in mind. So it's very good for storing and also reading out very large amounts of data or very large file. And when you get it up to streaming speed, it is very fast. But again, the benefits of like for disk is that you can get very quick access. Access to first byte is very fast, and then since disk uses a spindle, that you get you can get fast access for random access as well.
One more question, or too many questions.
Sure.
What's your cache to tape ratio in your big jukebox?
Oh, okay, cache, that's a good question. That would actually depend on the customer's workflow, so it's hard to say. Obviously, since our system, we want to deliver the cost benefits of tape, the majority of the customer will be, the majority of the capacity will be tape, but we will, depending on, let's say, like how much data the customer wants to ingest to the system in the day, or what the maximum would be, or how much data that they would be reading out periodically. Depending on such factors, we would have to scale the disk capacity. And so that would be kind of case by case. Sure, please. Yes, we are planning, okay. We are planning to support tape compaction in a future release, not the initial release. That is a request that we get from a lot of tape customers. And we'll support that together with tape migration. So migrating data from lower generations to higher generations of LTO. And during that process, we can also do the tape compaction. So I think we're out of time. Maybe just one. Maybe we'll take that one last question.
In a multi-data center scenario, is there a way that your object tape system in site A and site B can be hosted behind a load balancer? In case site A goes down, you can still read the same.
So that's something that we have not exactly put into our roadmap yet, but. And that's something that could be provided by the object storage layer, but we will, if we get a lot of requests, we'll look into that as well. Yeah, thank you. All right, thank you very much.